The broadcast is now starting. All attendees are in listen-only mode.
Hey everybody, hope you guys enjoyed their weekend. Today we will be using the Kerbal Space Program, so I hope you guys are excited about that. We will mainly just be going through that system, designing our rocket, and then on Wednesday we'll be flying them and working on getting those into orbit and how to keep them up in orbit. Hopefully we'll be able to move outside our vehicle a little bit and try out some space maneuvers as well. So I have really enjoyed, this game was new to me as well last week, but I've really enjoyed moving through it. It has a lot of really sophisticated uh, software. It's based off of real science, but if you guys have gotten to look around the game a little bit, you'll be able to tell that some of the words and terms are made up. You know, the moon is called MUN, the moon. So things aren't exactly, they line up, but they're not necessarily a tool you'd be able to find in a real rocket if you Googled that term. But they are supposed to mimic tools that are found in real rockets. And this is not a game where you can just open it up and say, oh, that looks like the top of a rocket. That looks like the body. That looks like the engine, and just put them together and press launch. It's really sophisticated. You have to understand how the parts fit together, and how much of each that you need. So today we're going to get into really basic rockets that will be able to get us up into orbit and back down to Earth. All right, does anyone have any questions? Let's see here. Oh, Nico has 3 in orbit. Great, Nico, I'm glad you're enjoying it. Wow, yeah, it's a full game. Apparently, Nico says that you can actually build a space station, which just sounds awesome. I know the game, that must be really challenging. So, way to go. I would love your input if you see something that I'm doing that is, the more difficult way to do it. Just, go ahead and let me know. Any other questions before we get started? No? All right, so I would like a show of hands on who has already downloaded the Kerbal Space Program. All right, okay, great. So I'm going to put your hands down. That's the majority of class. If you don't have it downloaded, if you don't have a computer you can download it on, feel free to message me. Oh, Mia, no worries. No one had to play it beforehand. That was only if you were excited. I'm glad that you can be here even with your homework. I completely understand that. It's coming to be the end of the school year, and they really like to kind of throw everything at you right at the end. I am, this lesson is going to be from the base up. So if you've played it at all, then you might think, oh, I already know this. But I might have some helpful hints because I'm coming at it more from the engineering design standpoint, and some of the things that I'm saying aren't even necessary for the game per se, but it would be how a real engineer would design the rocket, right? And let me see, what else was I going to say? Okay, I have the link here. I'm going to send it over chat, and tonight I'll post it when I post the video. As well. If you guys could get this for Wednesday, I'd really appreciate it. Send me a message if you're having trouble with it. We're not going to spend too long with Kerbal, so don't worry. Again, we'll be switching to other subjects. If you can't get it, that's okay, but it's a really fun game. It's free. It's not going to hurt your computer. You do just go to this website and download it for your appropriate operating system. All right, and we're getting the free one for now, the demo, for you guys to try it out. You know, with as much science and engineering that goes into it, and after we're done with this, I can show you guys more tutorials, or where you can find more tutorials. It really is a great investment in terms of a computer game. You're learning a lot about how that design process works and the space program. It's very thorough. So we're going to start off today with a bit of a review over some of the commands and the controls and how today is going to work. We are going to stick pretty much to my PowerPoint for the first half of class, and then I'm going to switch it into the Kerbal Space Program, and we're going to go through it together on the game. All right, I will try to switch out when I remember and check if we have questions. Sorry that I can't see if you guys have a question, so just hang in there if you have a question, and I'm moving a little fast. Oh. Nico says his advice so far is to don't press space accidentally. And we'll talk about that later and why, if you're flying, that can be a really bad thing to press space. Kind of sends you down the wrong road. Alright, so KSP, or Kerbal Space Program, is a game where the players create and manage their own space program. If you get the full game, you are actually able to go into space and construct, that what Nico's doing, construct that space station that orbits your space. So that's very cool. You can build spacecraft, fly them, and try to help the Kerbals to fulfill their ultimate mission of conquering space. And how we're going to be playing it is we're playing in the sandbox mode, quote unquote, which just means we have access to build the rockets. But if you get the full game, it kind of helps you out. It's more step by step, and you go through and learn, okay, this is what the first lesson is, and as you move through. So you're not, when we open this game, it's going to feel very foreign and difficult, but the actual game, it's a little bit easier to understand and get a grasp of. Alright, so when you start a new game, this is your Kerbal Space Center. This is your space hangar where you build space planes. This is the Vehicle Assembly Building, the VAB, where you build rockets, and we'll be spending most of our time here today. This is the launch pad where you can launch your rockets. And this is the, what do they call it? The tracking station, where you can track the progress of your missions. So, as Nico said, he has 3 spaceships, rockets in orbit right now. So what you can actually do is launch your rocket, get it into orbit, as we'll see, and then come back and work on something else. And then check back and see how it's doing. All right. And we're going to be going through this vehicle assembly building tutorial, the basic rocket design tutorial that was written by Senshi. It's a really nice tutorial because it describes kind of the why behind what we're doing and not just how to build a rocket that works, which you guys can definitely find, but we're really interested in why they're doing this and how this corresponds to how rockets fly. So the rocket that we're going to be building today is really just designed to get us into space, into orbit, and back home in just the simplest way possible. And so, there might be times where you guys are like, oh, I see this part, it looks better. And I definitely want you guys to mess around with that. Try to figure out ways where you could lessen weight, increase thrust. Go into those designs later, and I will show you more tutorials later on how you can optimize it and mess with it. But just, we're doing this basic rocket design so that we can understand the parts. All right. So, and we'll see this in the game, but there are placement helpers that help us because it's really important that the rocket, the tools and pieces that we add to our rocket are symmetric on the rocket. It's important for center of mass and center of thrust, and we're going to talk about why those are so important for stability. We saw that a little bit with our hot air balloon, and that's actually the same with rockets as well. It's really, that placement is very important with stability. So symmetry, when we need to add multiples of things to our rocket, we can click through these symmetry points modes, and there's 1, 2, 3, 4, 6, and 8 are the different modes, and that allows us to add multiple, thrusts, engines, different things that we would need to be adding to our rocket on the sides, equidistant from each other, depending on how many we need to add. Angular snap, you activate this, it's an on-off toggle. We always want to enable this. If it is off, then you can place whatever you're putting on there at any point on the rocket. But if you turn it on, it places the item that you want on there based off of a 22.5 angle, it breaks it into more of a polygon shape, and it's just going to be better. It's more optimal in terms of center of mass placement. So we're going to want our angular snap on. All right, and those are the different modes. There are physical indicators that we can turn on and off so that we can see how what we're adding is affecting center of mass, center of lift, and center of thrust. Center of lift is for atmospheric vehicles like planes, so we're not going to worry about it too much with what we are building today. Center of mass and center of thrust are very important, and it's for stability. Both should be horizontally centered. And what I mean by that is if you have this vertical rocket, both should be in the absolute center of that as it moves up and down, even as they move up and down. You don't want one side of your rocket being heavier than the other side or having more thrust than the other side. You want them to be this kind of the center, horizontally centered. And the center of mass should be in the lower third of your rocket, and that's going to keep it more stable. It's also going to keep it closer to your center of thrust, which is also very important for stability. If it's above, your rocket will be top heavy, and it's going to be more difficult to control during ascent. If it's really, really heavy and you have all your engines down here, it's going to make this part, really wobbly. And it's just, if you guys just try to even imagine it, it's a lot easier to hold something from its heaviest part as opposed to trying to hold it from its lightest part and having that heaviest part in the air. And that's because the heaviest part is going to want to fall down due to gravity. It's the most affected by gravity, in a way. It has more mass, so the acceleration is going to be greater. And the force is going to be greater. All right. So you're going to want that center of mass to be, and you can't lower it by just, trying to grab that center of mass indicator and pulling it down. It's the way the rocket is constructed that's going to matter. Your center of mass will change dramatically during flight as fuel is burnt up and as stages are decoupled. And what that phrase means is that we are going to be building these rockets and they're going to end up shedding parts, shedding fuel tanks and engines. And if you guys have ever seen a spaceship, actually, we should definitely watch a movie, a little short clip of a rocket being launched. It is very cool to see, very incredible. And I hope all of you guys have gotten the chance to see that, but maybe we'll do that on Wednesday as well. But parts of it are released during flight, and those, in real life, those have parachutes and float down, and they can actually be reused. All right, and then the last thing, you can rotate pieces that you're adding to your rocket using your W, A, S, D, Q, and E pieces, and that will rotate them 90 degrees. If you want to rotate, pressing each of these will rotate them in a different direction 90 degrees. If you want gradual rotation, you hold down the Shift key and then press those buttons. So we're going to jump off and see if we have any questions. Oh, wow. Nika says he has one of his spacecrafts is actually orbiting the moon right now, which is just very cool. Cool little preview of the game. All right, so designing payload. Payload is the carrying capacity of an aircraft or a spaceship. It's what we're referring to when we talk about that front or top piece that's going to hold cargo, munitions, scientific instruments. It also refers to extra fuel, but that's not really what, that's in the technical definition. But when we're talking about payload, we're kind of talking about that ultimate piece of spacecraft that we're sending into space. And we're sending it into space using the launch vehicle, which is going to be decoupled or, kind of shed from our vehicle as we get out of the atmosphere, and we don't need all of that weight anymore. We've already used all the fuel, so we can just detach it and it'll be sent back down to Earth, and then we can continue with, without all that heavy equipment. That kind of part is called the payload. So we're going to design that first, and then we're going to use that to kind of determine how large of a launch vehicle we need. For our payload, we're going to use the Command Pod MK1 as our command module. And a command module is where your crew is. And if for the demo mode, you only have one option, and it's the Command Pod MK1. If you had the game, you would have more options, and they would allow you to have more of our Kerbal guys in there. This one only allows one. It would also allow you to have an unmanned crew, so it would just be, kind of computers controlling the spacecraft. And that's important to consider for weight, how much supplies you need to bring up, etc. We don't have control over that. We're going to have that one guy. And attached to that, we're going to have these thruster blocks, and we're going to talk about that in a little bit. And they are symmetrically attached to that command pod. All right, we're also going to have a rechargeable battery bank. This is not in the demo. This is the only piece that's actually not in the demo, so we're not really going to have it. But the reason that you have batteries in the game, it's, in a real space flight, you need to be able to have access to electric energy. It's necessary for devices on rockets that run off of that, like computers and the different scientific equipment. The easiest way is battery packets. And for prolonged periods of time, though, spacecraft needs generating energy. So real rockets, outside of this Kerbal Space Program, they use thermoelectric generators, or they'll use a liquid engine, and that's going to produce an electric current while running. That's not really efficient, though. That's like using a gasoline engine for electricity. It's a possibility, but it's not probably what's going to happen. The most efficient way, and one that's often used, are solar panels, and those are used for long-term flights because they have this really high output at no cost, and they're fairly lightweight. But they're bulky and they can't take a lot of physical stress. They break pretty easily. And what you do is you have battery packs on your spaceship that run all of the electrical equipment, and then the solar panels, generally there are 2 solar panels, one on each side of the rocket. They come out whenever they're on the side of the planet it's orbiting that is encountering the sun, and they recharge those battery packs. They're mounted radially, which means they're mounted on the side. And again, those would not be used to power the spaceship. They are only being used to power kind of the electronics aboard the spaceship. What's being used to power the space, rocket, I should say, when it's up there, the payload. So this is not, these thruster blocks, what I'm talking about right now, is not what gets the rocket off the ground. It's what's controlling the rocket once it's in space. And that's this RCS. We have RCS thrusters, and we also have this RCS fuel tank and more thrusters. We're going to get back to those in a second. Underneath the command pod, we have this SAS module. And what the SAS module is responsible for, it's stabilizing the trajectory of our rocket. And we control it with the T key. It's toggled. All right, and what it can't save a rocket that is completely out of control. So if you design a rocket that is very top heavy, your SAS module is not going to be able to get it into space. But it can just ensure, kind of help the rocket get up into space, just like fins help a model rocket maintain a smooth path. Not just like, but in a similar way. All right. You could add multiple SAS modules, but it's a large increase in weight, and it's just better to design a better rocket that doesn't need multiple ones. And so the SAS module works in correspondence with these RCS thrusters. And let's talk a little bit about RCS thrusters and how they work. They work using fuel from the RCS fuel tank, and that kind of fuel is called a monopropellant. And this RCS is a simple thruster system that produces thrust by expelling compressed gas. And it's for fast course alterations and precise orbital corrections in space, like docking maneuvers. So it's how they are able to, once already launched into space, how they're able to make these kind of small alterations to their path when they are close to orbit. All right, and so they, let me see here. Thrust is very low for these because the purpose is precise directional change in a vacuum that has no drag and no gravity. But they also work with, these RCS can work with the SAS while it's getting up into space. It's just going to burn through a lot of that fuel. And it would only be used very small amounts just to kind of get that rocket back on path. All right. They are lightweight, omnidirectional, which means they can go in any direction, and we'll see that. And the fuel consumption is extremely low, but it does use a special fuel, so you would have to, kind of bring that along in this special fuel tank. Does anyone have any questions? Oh, Mia, I'm sorry you're having internet issues. This is all being recorded, and I think I will actually use this lesson, this 3:30 lesson today. So hopefully you'll be able to catch that again. Let me make sure we don't have anyone with their hand up. No. Good. And so we have our fuel tank below our SAS module, right? And that's for stability, this SAS module. And our fuel tank provides fuel to our 5 different thruster blocks. 2 are connected to the command pod, and 2 are connected to the fuel tank. And when we get actually into the game, we'll see what this looks like. The last part of our payload is going to be our MK16 parachute. And parachutes are necessary for safe descent for Kerbals. Placing them at the top of your rocket is kind of the safest bet for how to get your rocket down. But if your rocket is really long or really tall, then you're going to want to use a single radial parachute mounted at where your center of mass is. All right, and so that finishes the payload. You have your command module where your crew is. Below that, you have your SAS module that handles stability, your fuel tank, and then at the top and bottom there, you have your different thrusters for control that will create thrust in any direction. And then there's a parachute at the very top. Now, to get this payload into space, we're going to use a launch vehicle. What's going to separate your payload, right below your payload, is going to be this first piece here called the stack decoupler. And a stack decoupler is going to be what is used to separate the launch vehicle from the payload. And it's a ring that allows for a small explosion that separates the top from the bottom. Below that, we're going to have a fuel tank. And let's talk a little bit about the two kinds of fuel that we'll be using. We'll have a liquid fuel engine attached directly to our rocket. And then attached to that, we will have 3 more decouplers. So 3 more kind of pieces that will allow us to separate whatever connected to them. And to these decouplers, we're going to attach solid fuel boosters. All right, so let's talk about this a little bit. What's going to happen is the rocket is going to launch, and it is going to launch from Earth using solid fuel, using these solid fuel boosters. And then once it gets high enough in the atmosphere, those solid fuel boosters are going to decouple. They're going to come off of the rocket. And the rocket is going to start using liquid fuel. So let's talk about why we're doing that. There are 2 types of main propellant to generate large enough amounts of thrust to get the rocket into up and out of atmosphere. Solid and liquid fuel. Solid fuel burns with full power as soon as it is ignited, and it burns with that full power until it's completely gone. It's somewhat better thrust to weight ratio, so you can use it, it's going to be less heavy for how much thrust you get out of it than liquid. It's cheaper, and it is technically recyclable. And that's what we're going to be using in that first stage, because we just want a lot of thrust all at once. We don't need to control it. We're going to use, the closer we are to Earth, the more gravity, and the more we have to overcome that. So we're going to use, kind of like full engines ahead, full steam ahead, get up there. Then those are, once we are all out of that fuel, we are going to decouple those solid fuel boosters. And we're going to operate off of liquid fuel. And liquid fuel is burnt in a controlled fashion. It allows alterations of thrust levels during flight. So once we are up more and we are trying to achieve orbit, and where we want to orbit, we can use our liquid fuel engine, and that way we can control how much fuel is being burned. All right, let's see here. And on top of these boosters, we're going to place nose cones because that will reduce drag. And this will get our Kerbal, our one Kerbal space crew, into space, into a low, quote-unquote, Kerbin orbit, and it will allow us to test EVA, which we will hopefully be able to come outside of our rocket. We can send that guy out and kind of test being out in space, and we can test our RCS thrust system, simple maneuvering out in space with our rocket, and then return our Kerbal back home safely. That's our goal. Any questions? No questions? All right, so it is 3:59, and I want to go ahead and move into the game. So I'm going to give everyone 5 minutes until kind of 4:05 to get the game up and running. So go ahead, if you don't have it, now would be a great time to go to that website that I sent you and start downloading it. Go ahead and open the game. You can raise your hand when you're ready to continue, and you can also send me a message if you have a question or Mia, what happened is you removed it from that folder. So I would keep the icon in the folder for now. Just because I bet it's acting strange, a little strange since it's the demo. Keep it in the folder. And if you want, you can create the shortcut by taking the whole KSP folder and moving that to your desktop. So just pull that icon back into that folder. Again, whenever you're ready to continue, just go ahead and raise your hand. Good idea, Mia. Alright, so some people say that their screen is a bit too big. If you're still opening the game, that's fine. I'm going to go in and show you guys how to change that. Go into Settings, because the same thing happened to me. Graphics, and change your screen resolution. I hit 1 over and that worked for me. But you can try different things. And then press Accept or Apply. You might have to go into full screen to do that, and then quit out and it should open again, not in full screen. Or hit full screen, hit Apply. Once in there, unclick full screen, and then hit Apply after you've applied the other screen resolution. I love full screen's great, but I also like being able to see if you guys have questions. So, all right, guys. So make sure you're either messaging me or raising your hand when you are ready to continue. If that means that you don't have the game, still raise your hand so I know. If that means you have the game and it's up. Jeremy, go in once you're in settings and you're in graphics. Oh, okay, I see what you're saying here. Go to the right corner, and there's going to be a full screen icon in that right corner as well. All right, I'm going to put everyone's hands down. It is 4:05, so we do have to continue. But before we do continue, I appreciate that, Mia, you saying that. You don't have that button, Jeremy. Ooh, okay. Is there a way? Let me think. Is there anything in the right corner? Maybe double click even? It's going to be down here, so if there's a way you can even just try to hit accept or apply. That's my only advice. Okay, sorry, Jeremy. I can help you at another point. All right. Let's jump into this. So we are going to go into start game. I'm going to resume a saved game, but you can start new. And we're going to go to our vehicle assembly building. And let's start building our aircraft. And we are going to start with our command module. Right? So this is this selection here, our command pod MK1. We can click that. And I want to remind us of some controls that we have. If you can right click, you can move around on your screen, rotate. You can right click, you can use your mouse wheel, or if you're in a Mac laptop, you can either use 2 fingers and scroll up and down. If you hold down shift and use your mouse wheel, then you can zoom in and out. You can also rotate using your arrow keys. All right. Jeremy, there might be a window here. If you click window up top and go to full screen, that might help. All right. And you can move that around as well. So here's our command module. It's where our little guy is going to sit and control everything. And below that, we are going to have our RCS fuel tank. All right, and then we are going to connect to that RCS fuel tank and that's under propulsion is where I got that RCS fuel tank. And we're going to connect to that some controls. We're going to connect these thruster blocks. And to do that, we're going to use symmetry, right? First of all, I should have done this before, but we want to turn angle snap on by clicking that button there. And when it looks more like a polygon, we know angle snap is on. And we want to turn symmetry on. We're going to have 2 thruster blocks connected to our command module. So let's turn symmetry mode on there. I clicked it once and we're in 2. We're going to have 3 of them, 3 thruster blocks connected to our fuel tank. So I clicked it again and got into symmetry mode 3. And see now how it's not smooth, it kind of is choppy along here as I place, and that's because I have my angle snap on. We can also turn our center of mass on to see how that's doing and turn it off again with those icons. Great, Jeremy, I'm glad you got to work. All right. So now we have our command module and our thrusters that will help us move in space and the fuel for those thrusters. Our next step is to add our stability, which is our SAS module. We're not going to get the advanced module. For now, we're just going to use this basic one. If you can see the manufacturers, one is found lying by the side of the road and Steedler Engineering Corps. So I know this one may not seem very good right now, but it's all we need. In terms of weight, it's better. All right. And then the last thing that we need for this rocket is going to be our parachute. And our parachute is up here in utility. It's the MK16 parachute under utility, and it attaches up top here. All right, and so we are now done with the payload, and we can add the launch vehicle. This is what our payload looks like. And so the first piece that we add to the payload is going to be this structural piece, the decoupler, that's going to separate the payload from the launch vehicle. So this stack decoupler. And below that, we want our first fuel tank. And we're going to be using the FLT800 fuel tank, which is found under propulsion. I'm going to zoom out a little bit by holding Shift down and also pulling that command module up. If you try to pull any piece up, they'll break apart, but if you click that command module, you'll be highlighting the whole piece. So we have our fuel and our decoupler, and now I am going to add the liquid engine. Oh, Robert. Hey, Robert, what's your question?
My question is, when I added on the fuel tank, it went through the floor. How do I raise the rocket up so that there's
You
space
grab
under?
that command module and you can move the whole rocket up.
Okay.
And you can zoom out as well by pressing Shift and zooming out with if you have an arrow key.
Okay. Yes, thank you.
No problem. All right, so now let's add our liquid fuel engine. And for this one, we are going to use just the T30. We still need to add that a solid fuel that's going to get us off the ground. We want those to come off of the rocket though, so we're going to add radial decouplers that are added to the side of our rocket. And we're still in symmetry 3 mode, which is good because that's what we want to actually be in. So that was under structure, and it's the TT38K radial decoupler, symmetry mode 3. Oh. And to this, I'm going to add a solid fuel booster, which is under propulsion. There we go. And I've kind of struggled to get that to work every time, to get all 3 of them, but you want each to attach to a decoupler. I'll let everyone catch up for a minute. All right, so the next thing that we're going to add are our nose cones for these guys because we want just an aerodynamic rocket. They are under aerodynamic. Can add all three of those there, so I'm still under symmetry mode 3. Instead of nose cones, you could add, under utility, you could add parachutes. And that way these would actually, parachutes would be deployed, which is what I'm going to do. I'm going to grab those nose cones, bring them over here. When you bring an item over to this part where the tools are, it kind of disappears. I'm going to add parachutes to mine so that they fall into space instead of crashing. All right, so we talked a little bit about what's going to happen when our rocket moves, when it launches. And it goes through something called stages. And these stages, you can see them here. They are listed from 0 to 4. There are 5 different stages, but just like in program, they start with 0. And what's great is Kerbal kind of does these for you. So the 0th stage is actually going to happen last. So let's start with stage 4. The first thing that's going to happen is that, and you see when I go over 4, those engines light up. The first thing that's going to happen is those engines are going to start, and our rocket is going to be launched using those 3 engines. Notice that this liquid engine is not going to start right away. Neither are these. All right, and then stage 3, our decouplers are activated. That's what this means here, these decouplers here. And our parachutes are then activated. So our decouplers are activated, these guys are shot off, and then their parachutes work. Fall into space. I meant fall towards Earth, Jeremy. You can add the red structural support, Nico. It's not necessary for this situation. That's this one here for launching. You could just add 1 though. We can add that guy. That's what Nico was saying. It's this launch stability enhancer. You can add him. We'll talk about that more on Wednesday. All right, so then the next stage, after these guys fall off back towards Earth with their parachutes. Oh no. All right, oh. May not have the taps back correctly. We're going to worry about that on Wednesday. All right. Yeah, we'll get back to this launcher because it added it to a strange step. So I will get back to that on Wednesday. Hold on, let me grab my questions. They seem to have floated to my right here. All right, so next stage is stage 2. The liquid engine is on. So now our rocket is just this center piece, and our liquid engine turns on. The next stage is that we are up in orbit, so this decoupler is activated, and we just have this smaller payload. Our last stage is when our parachute is released. All right. And those are how stages work with these rockets. And you can actually, later on, you can go through action groups and kind of create your own stages. But for now, this is great. Much simpler to kind of have this. We can take a look at our center of mass and our center of thrust and see that they are close to each other. They're not ideal, but they are close to each other. And we can change that We can move these guys down. Oh no. Oh, see, I'm in symmetry mode 1. I had to switch back to symmetry mode 2. And it's going to change our center of thrust and our center of mass, because they are thrust as well. But we can try to change that around a little bit. Alright. And as our fuel is decreased, our center of mass will actually rise. We want to make sure it's stable. We are going to launch this one on Wednesday, but I do want to show you guys in kind of the remaining minutes how to launch a rocket so that you guys can kind of try that out. I will repeat though, guys, we will be launching and learning about launching and flying our rockets all through Wednesday. So just know that going into it. If you want to explore it on your own time, that's fine, but that's also what we will be doing in class and starting at just a very basic level. All right. So I'm going to go ahead, save your spacecraft as whatever you want to call it. Save mine as my 330 class rocket. You can add, oh, you do not need them, but you can, if you want to, add fins. I know other people were interested in that. You can add these little winglets, but they are just going to add to your mass. These are for space planes, but someone wanted to add them. You can try. Go for it. Once you save it, you can go ahead. I want you guys to load Kerbal 1A. When you load that, and that was under that launch, or under this load button here. And we're going to launch this guy by pressing that launch. All right, and now that we're here on the launch pad, this is how we go. We wait until this purple light flashes green, and that means that we're ready for the next stage. So we are going to hit shift until our throttle it reaches kind of the peak amount, and then space bar. And we kind of hit drift. Some people, you might want to actually go down. You can decrease the throttle a little bit since it's liquid fuel by hitting control. You might want to be more close to 90%. We can see our fuel decreasing. That purple light flashing between green and purple means we're not ready for that next stage. So we're burnt out. We got the green flashing light. I'm going to hit space bar, and that activated the next stage again. Oh dear. That was incorrect. There was a crash. All right. I'm going to activate my parachute. Oh no, guys. This was a crash. We'll go more into flight on Wednesday. It is very complicated software. It does not always work out. Maybe Nico knows what I did wrong there. I might have activated it too soon. I might have activated it. I bet I activated my parachute too soon, that's for sure. I bet that's going to rip off because we're still way too far up for a parachute. But, sorry, Kerbal. We can kind of see my Kerbal guy is very afraid. Sorry, Ronzer Kerman. Let's try that again. And you can just try it again by hitting resources. Oh, I think I can time warp and then, ooh, it won't let me time warp. see here. Okay, there we go. I can end the flight, but I hit escape to end the flight, end flight, and then restart flight. Let's try that again. All right. So again, when we get that green light, hit shift to the full throttle and press space bar. Yeah, saved Kerman just in time by hitting escape. He's fine. We're here now. Oh. All right, that worked. Maybe. Let's see. Still no. Man, we had some successful flights at 1:30, guys. Let's try that one more time. It's 4:27. I'm gonna see if maybe I don't up the throttle. See, I'm hitting shift here. If I only up the throttle to 90, if that will work better for me. All right. So someone has their hand raised. Hey, Robert, what's your question?
Oh, well, I was gonna ask how do you go back and restart, but I found out.
Escape?
So
Okay.
it's okay.
Good. So we will go into more of the flight, being able to do the thrust. I do not know, guys, why that keeps happening. I will definitely have it better for Wednesday. I do know this is only working on that liquid fuel and is not working at all on, it might just be that this spacecraft doesn't have enough fuel, but I got it to work earlier. So, we'll work through it together. We'll get it on Wednesday. So you guys can mess around with that. Test out your parachute again. We're clearly not high enough since we're still in atmosphere. But all right, guys, I will see you on Wednesday. Sorry, I couldn't have left this on a more uplifting note. Again, escape is how you end your flight, and you can either end it and go back to the Space Center, or and you can try out other spacecraft too instead of 1A. You can try out. They have a more complicated, the Kerbal 5 might be a little better for you. So, I will see you guys then. Have a great Monday afternoon. Bye, guys.